subscribe. Click on the bell. Like, comment, share.
Things around us like plants, animals, building, food, water, even the air we breathe in are matter. Matter exists in 3 states: solid, liquid, and gas. All matter has mass and it occupies space. Matter is made up from a tiny and discrete particle. And particles are too small to be seen. However, the largest particle known is the gold atom. This is how the gold atom looks like under an electron microscope. The radius of a single atom is 0.4442 nanometer. Let's do some activities to prove that particles in matter are tiny, discrete, and occupy space. Click on the play button to start. Pour 50 cubic centimeters of water into cylinder A and do the same with cylinder B. Now we have 2 cylinders with the same amount of water. If water from cylinder B is poured into cylinder A, will the total volume become 100 cubic centimeters? Click on cylinder A.
Yes, as expected, when 50 cubic centimeter of water from cylinder B is added to 50 cubic centimeter of water into cylinder A, the total volume becomes 100 cubic centimeters.
Let's do another activity. This time we use 50 cubic centimeters of alcohol and 50 cubic centimeters of water. Will it give the same volume as before? Click on the play button. Can you explain why the final volume is not the same? The total volume is different in both activities. Why? In activity 1, there is only one type of particles involved. That is water particles. These particles are discrete and they will not combine to form one big particle. There is not much spaces between these particles. So the particles have to take up other empty spaces. In activity 2, there are 2 types of particles, which is water particles and alcohol particles. These particles are discrete and they will not combine to form one big particle. The spaces between the larger particles allow the smaller particles to diffuse and take up empty spaces between the larger particles. These activities show that particles are discrete and they occupy space. Diffusion is a process that depends on the random motion of particles. It is a common phenomenon to provide evidence of moving particles. We can carry out an experiment in the lab to prove this phenomenon. Click on the tab to begin.
Diffusion of gas.
A few drops of liquid bromine is placed into gas jar A. Gas jar A is quickly covered with a lid. Gas jar B is filled with air. Gas jar B is inverted on top of gas jar A. Click on the play button. The bromine molecules move from a region of higher concentration to a region of lower concentration until the concentration of both regions are the same.
Diffusion of solid.
A test tube is filled with hot liquid gel and left to harden. A small piece of potassium manganate 7 crystal is on top of the gel. Then the test tube is plugged with a rubber stopper. The test tube is clamped upside down and left for 2 days. Now, click on the play button to start the animation. The potassium manganate 7 crystal dissolves and diffuses very slowly into the gel due to the limited spaces for the particles to move.
Diffusion of liquid.
Would you like to carry out an investigation on diffusion of liquids? To carry out this investigation, you need a bottle of ink, a straw, retort stand, a clamp, test tube, and water. After you have done the experiment, submit your finding to the teacher and discuss it in class.
Which diffuse the fastest?
Click on the timer and observe what happens. What can you conclude about the rate of diffusion of solids, liquids, and gas? Discuss with your friend.
From the animation, we can conclude that all matter are made up of particles. Diffusion in gases is faster than diffusion in liquids. Diffusion in liquids is faster than diffusion in solids. The rate of diffusion depends upon the mass of particles. Click on the blinking button to proceed. Matters are made up of discrete and tiny particles. Do you know how these particles are arranged? How do these particles move?
Solid particles.
The particles in solids are closely packed in orderly manner. The forces of attraction between the particles are very strong. Therefore, the particles can only vibrate and rotate about their fixed positions.
Liquid particles.
The particles in liquids are loosely packed. The forces of attraction between the particles are strong, but not as strong as the force of attraction between solid particles. Therefore, the particles can move freely and collide with each other.
Gas particles.
The particles in gases are far apart from each other. The forces of attraction between the particles are very weak. Therefore, the particles can move freely and randomly. The particles collide with each other. The rate of collision in gas is higher than in liquid. Kinetic energy. At standard temperature and pressure, solid particles vibrate and rotate about their fixed position. As the temperature increases, more heat energy is absorbed, thus increasing the kinetic energy of the particles. The particles vibrate and rotate vigorously, and this weakens the force of attraction between the solid particles. The particles become more widely spaced and therefore become liquid. As the temperature increases, more and more heat energy is being absorbed by the particles and increase the kinetic energy of the particles even more. At this temperature, the liquid particles have gained enough energy to escape from the surface of the liquid. The particles become further apart from each other and move at random. And the particles collide with each other at higher rate than the liquid particles. Every substance in the world exists in solid, liquid, or gas. The state of matter changes if heat is absorbed or released. How does changes in heat affect the change in the state of matter?
Solid particles are compact and orderly arranged. There are only small empty spaces in between the particles. The forces of attraction between particles are very strong. Particles have low energy content.
The changes in the state of matter are caused by heating. Do you want to know what will happen when heat is applied to ice? Click on the Bunsen burner to find out.
When heat is applied, energy from the heat is absorbed. This increases the particle's kinetic energy. At the same time, the forces of attraction in between particles decrease. The particles become loosely arranged and not compact. The state now changes from solid to liquid. Liquid particles are loosely arranged and not compact. The spaces between each particle are larger. The particles can move freely from one point to another while still in contact with each other. The forces of particles are fairly strong. Its energy content is higher compared to solids.
What will happen if we continue heating the water? Click on the Bunsen burner to find out. When we add more heat to the liquid, the kinetic energy becomes greater and the forces of attraction between the particles are further reduced. The particles now spread far apart from each other. The state of matter now changes from liquid to gas. Gas particles spread far apart from each other, forming large empty spaces between the particles. The particles move in all directions. Gas particles have very weak forces of attraction with the highest energy content. Based on the examples given, we can see that there is a relationship between heat, kinetic energy of particles, and also the forces of attraction in between particles. When heat is given to a substance, its state of matter may change due to the changes in particles' kinetic energy and forces of attraction. When a substance is heated, its kinetic energy increases and the forces of attraction between particles are weaker.
Solid particles are compact and orderly arranged. There are only small empty spaces in between the particles. The forces of attraction between particles are very strong. Particles have low energy content. Liquid particles are loosely arranged and not compact. The spaces between each particle are larger. The particles can move freely from one point to another while still in contact with each other. The forces of particles are fairly strong. Its energy content is higher compared to solids. Gas particles spread further apart from each other, forming large empty spaces in between the particles. The particles can move very freely and randomly. Gas particles have very weak forces of attraction, with the highest energy content.
We know when heat is applied, particles will gain more energy. This causes its kinetic energy to increase and the forces of attraction in between particles to decrease. As a result, changes in the state of matter occurs. What will happen if we decrease the heat? Will the substance change into another state? Click on the Bunsen burner to turn off the heat.
When we remove heat from gas, energy is released from the substance. This will also reduce the kinetic energy. However, the forces of attraction in between the particles are increased, hence forming liquid.
Can liquid change into solid if we keep on decreasing the heat? Click on the Bunsen burner. When liquid is cooled, the kinetic energy is reduced. The movement of particles slows down and stronger forces of attraction between the particles are formed. When a substance is heated, it can change from solid to liquid, finally to gas and vice versa. If a gas is cooled, it can change from gas to liquid into solid. This is known as interconversion of matter. There are substances that change from solid to gas and vice versa without undergoing the liquid state. For example, iodine will change directly to gas when it is heated. Name of the changing process of matter. Matter changes when heated or cooked. When ice is heated, it changes to water. Ice is in solid form while water is in liquid form. The changing process from solid to liquid is called melting. When water is heated, it turns to gas. Can you guess the name of the process? Type the name of the process and then hit enter. Incorrect. Try again. There is another process which changes liquid to gas at any temperature and atmospheric pressure, but occurs only at the surface of the liquid. The process is called evaporation. When gas is cooled, it will condense and change into liquid. Now, type in the name of the process in the space provided and hit enter. Good. The process when gas changes to liquid is known as condensation. Liquid can freeze and become solid. Now, try guessing the name of this process. Fill in the blanks provided and hit enter. Good. The process when liquid is changed to solid is known as freezing. Some solid can change to gas without undergoing the liquid state. For example, iodine changes into gas when heated. What do you call this process? Good. The changing process from solid to gas and vice versa without undergoing the liquid state is called sublimation.
According to the kinetic theory of matter, matter is made up of tiny and discrete particles. There are three types of particles: atoms, molecules, and ions.
Observe the animation. What are the differences between atoms, molecules, and ions? Atoms are extremely tiny, much too small to see. Yet they make up all the world, including you and me. These are called atoms. An atom is neutral and the smallest possible particle of an element that can take part in a chemical reaction. Metals and some nonmetals, like carbon and helium, exist as atom. These are molecules. Molecules are made up of two or more atoms of the same or different elements. For example, carbon dioxide gas. Carbon dioxide is a molecule which made up of atoms of different element. Carbon atom and two oxygen atom. Another example is hydrogen gas. Hydrogen gas molecule is made up of two atoms of the same element, two hydrogen atoms. These are ions. Ions are charged particles. Ions are formed when an atom receives or donates electrons. For example, sodium atom becomes sodium ion when the electron valence is released to a nonmetal atom. Negatively charged ions or anion are produced when nonmetal atoms receive electrons. For example, chlorine atom becomes chlorine ion when receive an electron from a metal atom. In this lesson, you have learned that matter is anything that occupies space and has mass. Matter is made up of tiny and discrete particles. Matter exists in solid, liquid, and gas states. Diffusion of particles can occur in solids, liquids, and gases. The rate of diffusion in gas is faster than the diffusion in liquids. The rate of diffusion in liquids is faster than in solids. In this lesson, you have learnt about the atoms, molecules, and ions. Atom is the smallest particle of an element. Molecules are made up of two or more atoms of the same element or different elements. Ions are particles which are positively charged or negatively charged. In this lesson, you have learnt about the kinetic theory of matter. The kinetic theory of matter stated that matter is made up of particles which are constantly moving and contain kinetic energy. The particles in a solid are closely and compactly arranged and can only vibrate and rotate at fixed positions. Particles in a liquid are arranged less closely and less compactly and can move randomly within the volume they occupy. Particles in a gas are not arranged compactly and are widely spaced and move randomly at great speeds, causing collisions between each particles. A substance can be in any of the three states, which are solid, liquid, or gas. Particles of substance are in constant motion. However, increased heat energy will make particles move faster. This will then cause changes to the states of matter. When heat is applied to a substance, energy will be absorbed. This will increase particles' kinetic energy and reduces forces of attraction in between particles. On the other hand, when heat is removed from an element, its energy will be released. This then decreases particles' kinetic energy and increases forces of attraction in between particles.
Thanks for watching. Please subscribe and hit the bell icon.